class. Today we're going to be looking at section 1.5 day 2 for college algebra, which is learning how to solve quadratics or graph quadratics by completing the square. So this is going to be new. I don't think you've done this in any of the other classes yet. Right, so we're going to start off by looking at the standard form of a quadratic. Sometimes this is called vertex form of a quadratic. It just depends on your textbook. The textbook we're using calls it standard form. So, but it's the same as what we had in our previous course called vertex form. You can see here, f of x equals a, and then parentheses times x minus h squared plus k. And the vertex is the point hk. So this is a really, really nice form to have if our goal is to graph our functions. For example, and I'll just run through this kind of quickly. If I have this vertex form quadratic equation, I can tell what the vertex is by using, let me use some colors here, this term and this term, but I need the opposite sign for this one and the same sign for this one. So my vertex is going to be positive 3, positive 8. And I can plug that onto my graph or plot it onto my graph right now if I want. 3, 8 is going to be this point here. Now, one of the other things that's nice to know is based on the a value, whether or not it's positive or negative will tell you if your parabola is going to open up or down. In this case, we have a is less than 0, so it's going to open down. So I know that my parabola is going to be shaped like this. And I can, the way I teach this is once you plot your vertex, we can rewrite the equation without it. So without the vertex in there, the equation is f of x equals negative 2x squared. If I make a table of values from this simplified form of my equation, and I call these over-ups when I'm teaching, and I call them over-ups because they're not really x and y coordinates. They're movements over and up or down from the vertex. So it just simplifies my work a little bit. Instead of having to plug numbers into the entire equation from the beginning, I have a much simpler form. And then I usually just use negative 2, negative 1, 0, 1, and 2 to go over from the vertex both directions. And then we can plug that in. Negative 2 times negative 2 squared is negative 8. Remember, we square first. So order of operations, exponents come before multiplication. Negative 2 times negative 1 squared is negative 2. Negative 2 times 0 squared is 0. Negative 2 times 1 squared is also negative 2 because if I square 1 or I square negative 1, I get the same thing. Similarly, for positive 2, we also get negative 8. So we have that beautiful symmetry that we see with our parabolas. And I can graph these over and up movements from the vertex. So by taking the vertex out of my equation, in terms, we kind of just shifted our entire unit or our entire parabola over and up, and then I can just figure out how it opens from there. So from and I'll use a color here just so you can really see what I'm doing. From here, if I go over to this direction and I go down 8, so over negative 2, up negative 8, I end up with a point right here. So you can see that movement from the vertex. And then I'm going to do the rest kind of quickly. If I go over negative 1, I'm going to go down 2, over from the vertex, positive 1 down 2, and positive 2 down 8. Now I can keep going if I want more points. I might be able to fit them. Actually, I think I can fit them if I go over 3. I always like, so if I go over 3, negative 2 times 3 squared is 9 times negative 2 is negative 18. So I can just barely fit that on my graph. And I always try to find enough points, as many points that'll fit on my graph so that I get a really accurate shape and I don't go wrong while I'm kind of connecting my dots here. And then we connect, and graphing from vertex form is definitely one of the easiest forms to use when graphing quadratics. So what we're going to do for the rest of the lesson is learn how to get a quadratic equation or a quadratic function into this vertex standard form so that then we could take it from there and graph or solve. I'll show you how to solve as well. All right, so completing the square, there's multiple steps. The first step we want to do, and we're going to list these on the side, is get the equation in the form f of x equals a. If there's an a value, right now our a value is 1, so it's not going to apply to this problem. We'll see an example like that later. Times x squared plus bx, and then we're going to leave a blank, and we're going to kind of move the c value over, and then we're going to put another blank next to that. So let's just do that first step, and then we'll kind of go step by step here. So the first thing I'm going to do is just reformat this a little bit. There's no a value to factor out. So in this case, I'm just going to have x squared plus 10x plus blank minus 15 plus blank. So I didn't really do much other than just restructure this a little bit. The next step is we're going to complete the square. What that means is I want to get, if we look back up here at what vertex form looks like, I need to get a perfect square trinomial so that I can put it in factored form as x plus or minus something squared. So here I want to end up with x plus or minus something squared, and then plus or minus the rest of our equation. So that's why we call it completing the square. In order to do that, we are going to find the middle term, which is b, divided by 2. And your b term is going to be whatever's left after you factor out an a value, if you have that in your problem. And then we're going to square it. And then we're going to add and subtract to the blanks. So if I take 10, so b over 2 squared is going to be 10 divided by 2 squared. 5 squared is 25. So what I'm going to do is I'm going to, actually, I think I'm going to rewrite that before I jump ahead of myself. So x squared plus 10x plus 25 minus 15 plus, and then I can't just add 25 to my equation. I need to zero that back out, so I'm not actually changing what I had. So I'm going to add a negative 25. So my positive 25 and my negative 25 cancel each other out, so I didn't really change what I had. And then we factor. So step 3 is factor. We've created that perfect square trinomial, so if it doesn't factor into a perfect square, you did something wrong. Go back and check it again. So if I look, factors of 25 that add to 10 are 5 and 5. So I'm going to end up with x plus 5 times x plus 5. And then I can combine these, minus 40. And then I'm going to simplify this to x plus 5 squared minus 40. So there's that vertex form that we can see here. Simplify, I guess, would be our last step if needed. So that's the whole thing with completing the square. We're going to do another example where we do have that a value next, or in a couple problems. All right, so next page, we are going to just practice the b over 2 squared piece. What term should be added? So if you wanted to pause the video right now and do problem A, do the b over 2 squared and see what should go in that blank. So 8 divided by 2 squared gives me 4 squared, which is 16. So that blank should be 16 to complete that square. Now this one's a little different. Negative 7 divided by 2 squared. It's not going to be a whole number, and it's okay. And as weird as it is, we actually are just going to leave it in fraction form, 49 over 4. So you square the numerator and the denominator. So this is going to be 49 over 4. Now in our class, I'm not going to give you any of these problems to do with fractions. You might see a couple in your homework, but on tests and quizzes, it'll be whole numbers mostly. But if you go forward in math, like to pre-calculus or something like that, you might have to factor with fractions. It's not as scary as it looks, but you'll figure it out when you get there. All right, I'm going to leave example 4A up to you guys. So if you wanted to try that, make sure to check your answers with the filled in notes on my calendar for our course. And we're going to come down here to part B. So this has that other step that we didn't really see happen in the other example I did, which was that first step where we have to factor the A out before we can do our format. So we have an a value here, and it's really, really important that you know we are only going to factor the a out of the first two terms. And I know 2, our a value, doesn't factor out a 9, but even if it had, even if that 9 was a 10, we still wouldn't take the 2 out of it. It wouldn't be affected at all. So what I'm going to do is I'm going to take that 2 out. I have x squared minus 6x plus blank. And then this 9 is, see how it's outside of that parentheses? The 2 isn't actually affecting it. So you want to make sure you leave that c value alone. Right. And then when we do our b over 2 squared, we're going to use our new b term, I guess, not the original one. So negative 6 over 2 squared is negative 3 squared, which is 9. So I'm not going to rewrite it this time. I'm just going to add 9 here. And then this one here is tricky when we have an a value we took out. It's not going to be negative 9 like it was in the first example, because this one right here is not really a 9. It's a 2 times 9. We have this 2, and if I bring it in, when I really think about what I added to my equation, I added 18. It's really a, let's see, I'm going to write a 2 times 9, which is 18. So here I'm going to balance that out by subtracting 18. So that opposite sign of 2 times 9. So that step gets tricky. It takes a little while to get used to that one for sure. All right, so now we can do the rest of this problem. We have 2. I'm going to factor that perfect square trinomial, and I'm just going to skip to where you see it squared. So that's going to be x minus 3 times x minus 3, or x minus 3 squared, and then plus 9 minus 18 gives me a negative 9. Now, we would have just stopped here if all we were trying to do is get it into this vertex form to graph, but this problem actually said to solve by completing the square, so we need to solve it from here. In the previous lesson, we looked at solving these using square roots, which is what we're going to do. So be careful. Do not multiply the x minus 3 times x minus 3 and then distribute, and you're going to end up with a whole lot longer of a problem. Easiest way to do this is just to isolate that x squared term. So we have 2 times x minus 3 squared equals 9. Divide both sides by 2. I'm going to move up here. I have x minus 3 squared equals 9 over 2. I'm going to leave it as 9 over 2 right now. And then I can square root both sides. So square root, don't forget your plus or minus. We talked about that in our last couple lessons. All right, so we have x minus 3 equals plus or minus the square root of 9 over 2. Now we can simplify, and actually we have to simplify the square root of 9 over 2. We're not allowed to leave square roots in the denominators or fractions in square roots. So what we're going to do is a little bit more work here. I might have to bleed down into this other problem. X minus 3 equals plus or minus. First thing I can do is split those square roots up, because the square root of 9 is a perfect square, and I can make that into a 3 over the square root of 2. I still have a square root in the denominator, which is a problem. We are going to rationalize that by multiplying it by itself and balancing it out on top. So that really I'm just multiplying by 1. In doing this, we end up with a 3 times the square root of 2 on the top, and on the bottom, square root of 2 times the square root of 2, square root of 4 is 2. So we've gotten rid of that square root that's not allowed to stay in the denominator. And then my last step, I need to still get x by itself, so I'm going to add 3, and x equals 3 plus or minus 3 root 2 over 2. You can leave your answer like this, or I think sometimes your textbook will make it as x equals 6 plus or minus 3 root 2 all divided by 2. That 6 divided by 2 is the 3, so this is the same thing. Don't freak out if you see that. All right, that was a lot and definitely needed more room than I had prepared here for this problem. So there's one more problem for you to practice here. I'm actually going to not do it to try to save some time on this video, but you can try it yourself and then copy it in from my notes that are posted on the calendar.